Welcome to TELO Talks, where we bring you inside our network of amazing people. Luminaries we rely on every day to inform us on technology, automotive history, engineering best practices, and more. All so we can build an epic company and deliver an amazing truck to you. Welcome to another episode of TELO Talks. We have with me today Marc Tarpenning, one of the original founders of Tesla Motors, and also an advisor of mine over several startups, including this one. Today, I just wanted to talk about anything you really want to talk about, Marc, but especially some of the early days at Tesla and any things that you would like to share with us that we could learn to do things right as we build this company. Not to make mistakes that have been made, or
I mean that is so broad. Yeah,
I know.
It's great to be here, Forrest. That's just a very, very broad mandate. I mean, there's all kinds of things that we did poorly and messed up on at when we were starting Tesla.
Yeah.
We have spoken about a couple of these things, and like one of them, which was quite funny, was you have all these parts. The car consists of thousands of parts, and you try to keep track of them, and the engineers specify these parts, and they put them all in the database. And one of the things that's in that database of parts is the weight of the part. We discovered when we went to build the car, which we thought we were within our weight budget, and for us weight really mattered because of our acceleration goals. We thought we were within the weight budget, but it turned out that if the engineer hadn't been able to figure out what the weight was going to be, they just left it blank, which was treated as a zero in the roll up. Suddenly all this extra weight started showing up as they actually were physically getting the parts and putting them on the car. And like, how could the car weigh so much more than the sum of its parts? We changed that rule that said that the default was like 10,000 kilograms or something, so that every time someone would add a part, if they didn't put something in it, the car would weigh, it would be like a black hole. And that was super helpful to actually get the weight to where we needed it to be.
That advice has been great. And on our team is Mike, and both Mike and I lived a little bit through that. I don't know if we were there the exact time, or if I was there the exact time that happens, but I do remember adding parts with other engineers to Arena when we first started. And if we couldn't fill in all of the fields, people just were like, we got to get this done, just like on to the next field, just leaving it blank. So Mike has spent a ton. He left Tesla, and started CleanWave, which is an electric motor company, sold that. And so he experienced some of those growing pains. And we recently made our chassis. We estimated it in Arena to see what the weight was, and it said it was 410 pounds, and we weighed it, and it was actually 420 pounds in real life. So we're getting there. We're pretty close. So
that's not bad. Have you found where those 10 pounds came from?
We think epoxy and rivets, because we didn't enter quantities of those. So
yeah, it all adds up.
Backing up a little bit, how was the original name found? Like, how did you guys? Who came up with the name?
Martin came up with it, and I can't remember the origin story exactly on that, but we were kind of looking around for names for sure. We needed to find one that you could get the URL for, which Tesla Motors. You couldn't get Tesla, but you could get Tesla Motors, though. At that time, Nikola Tesla was very unknown. I mean, obviously, there's a unit of measure named after him, but he was pretty obscure. Yep. Outside of the sort of EE geek community. We really liked the idea of something kind of honoring him, and then also he invented the AC induction motor. I mean, all those motor patents from the 1800s are AC induction motors, and he had letters that he had written to, I think, the mayor of New York City at the time, explaining how electric cars were going to be the future. Of course, he didn't expect it to take quite so long, but he was right. He just, all of that just came together, and we're like, we have to honor this thing, and it's a great name. And well, actually, if you talk to trademark and copyright people, they're like, it's a terrible name. Why would you do that? But it was good enough for us.
Yeah, I thought that was one of the things when I first joined. I was like, oh my God, that's an amazing name. Like, I built a Tesla coil in high school. I was into EVs. Tesla had this kind of, fringe scientist. Like, he was brilliant, but also misunderstood, and also a magician. So you didn't really know what was real and what was not quite real. So had a lot of mystique around him.
One of the things that happened to me recently, this last summer, actually, I was in Serbia and at the Nikola Tesla airport. You arrive in Serbia at the Nikola Tesla airport. They have a small museum dedicated to him in the city there. It's the only, so Nikola Tesla did this thing in the 1800s, which I'd always kind of wondered how he did. I hadn't researched it, but I knew had done this, where he had a remote control boat, and he built a lake, and he would drive it around in this lake, in the 1800s, and be able to control it, turn it off and on, and make it turn and stuff. And you can imagine, at a time before radio really even was around, it was freaking magic. Like, there was no question this guy was a wizard. And I'd always sort of wondered how that worked. And they had a replica of Nikola Tesla's boat, which you could play with, and you could see how it worked, and it was super cool.
I'll have to go there. That sounds like an amazing.
It's a small museum, but definitely worth it.
So I started in 2005. Tell me a little bit about, like, what was Tesla like between 2003 and 2005, or how? I mean, you and Martin had been working together. Maybe kind of just talk about the origin story a little bit.
Martin and I had done another company that had successfully exited, Nuva Media, in the 90s. It was an electronic book company, and we got acquired by, at that time, the world's largest publisher of magazines, which was TV Guide. It's hard to believe now, but they were a really big thing at the time, publicly traded and out there for a long time. So we got acquired by them, and that was quite exciting. One of the things that we had looked for with Nuva Media when we were starting that company was, what had changed. We had been in the electronics industry forever, and certain things started getting better and better and better, and you're like, well, what? This component is getting better. What can we do with that? And in this case, it was small handheld displays, which seems ridiculous now, but at the time in the 90s, display technology was really bad, and you couldn't render a screen. No screen could render a page well enough to actually read on it, other than just big letters, like time or whatever. We had seen, though, this display technology getting better and better and better. And we said, oh, well, we could make a book. We could make an electronic book, kind of like an early Kindle, if you will. That was great, and it worked. When we were doing Tesla, we were also looking around for something more meaningful. Martin was super interested in electric cars for a variety of personal reasons. The thing that we had seen was that batteries were getting better and better and better every year. And, we had nickel metal hydride, originally NiCads, but then nickel metal hydride when we were doing the ebooks. But then our last version of the ebook had gone to these new lithium ion cells, which were quite exciting. Every year they got better and cheaper and better and cheaper. So by 2003, when we started Tesla, there was this idea that, well, like, what is that upsetting? In electric cars, it's all about the battery. Suddenly battery technology is really a lot better and getting better and cheaper all the time. So the thing that costs the most to the car, the thing that really is the enabling technology, we're on somebody else's, sort of advancement and commodity curve. If we use lithium ion cells, if we could figure out how to make them all work and play well together, which was not obvious, but that was the sort of aha moment. And largely credited to Martin, as an electrical engineer. He's like, remember these batteries, Marc? We could really, I think we could do something really fun with a car. And that was, sort of the genesis of Tesla.
So, and did you form it in 2003, or what happened in the couple of years before I came on?
We formed it on, we've been talking about it for several months, and then we formed it officially, legally on July 1st, 2003, which was a little bit of a mistake because like a year and a half later, we discovered that Nikola Tesla's birthday was like July 10th. And if we had known, we would have delayed it, like a week and a half and ended it on his birthday, but we didn't know at the time. And it never occurred to me to go look. We spent a full 6 months trying to figure out if it would really work. We did all these models, both financial models and wrote a business plan, but also early, spreadsheet models of what a car could be like, with the battery technology that existed. And what the costs were likely to be. And by the end of that year, we had convinced ourselves that this was a possible thing. In December, Christmas time, we showed it to a few VCs that we knew could not invest. They were friends of ours or acquaintances. And we said, hey, we know that your fund can't do this, but we have this crazy idea we want to run past you. And the VCs were into it because, as it turned out, like, if you're only investing in optical routing, and you see optical router business plans every day, if you say, hey, I've got this electric sports car idea, the whole partnership shows up. They were so excited to hear something that wasn't an optical router, even though we knew that, and they knew that they couldn't invest. But they gave us lots of great feedback as to really poking at various aspects of our business plan, which changed our business plan actually along this process, so that in the first of 2004, we were able to go out and actually raise money with real people, including Elon. Elon was a lead investor of Series A, which was our first institutional round.
So you didn't do a seed round before that?
We had put in a couple $100,000 of our own money, just as convertible note kind of thing.
So that's, I mean, so he led that as an angel, or did he have a fund?
As an angel, I think. Yeah.
I mean, that's not typical, right?
It's not super typical, but if Larry Ellison or whatever is going to invest, he's going to write a check, whether it comes from some LLC he's created or whether it's just his own, from his checking account.
Right.
When you have those kind of resources, I don't think it matters too much.
Were there like negotiations around the term sheet? Like, how did that happen?
Oh, yeah. I mean, there always is. I mean, the term sheet was totally standard and vanilla. The issue, is typical with it's about valuation. That there was some negotiation on valuation. That was pretty much it. I mean, it's all these term sheets follow the sort of venture capital standard thing. So even then they did.
So was that connection to Elon? Was that from JB? Was that from the pilot kind of world, or was
no? So our connection to JB comes through Elon, but no, it was the other way around. We had met him one time briefly, and I'm not even sure he remembers this. He spoke at the Mars conference at Stanford, I want to say 2000. So it was before SpaceX, before he started SpaceX. And one of the things was he had been trying to do this experiment getting into space, and he discovered that launch costs were insanely high. So at that conference, he had said, we have to solve, the space industry as a whole has got to solve this launch cost problem, because the fundamentals don't suggest that it should cost millions of dollars or whatever to put a kilogram into orbit. A year later, he started SpaceX, and then the year after that, we met him again. The second time, we had been helping out AC Propulsion, which was a sort of hobbyist electric car company down in Southern California, and they had some connection to him. I think was how they said, "Oh, Elon is kind of interested in this. You should go talk to him."
So when did JB get involved?
He was employee number 5, I think, or 6. Mm-hmm. Yeah, so early on, once we got funding, we were hiring, and we shake all the trees for people who are interested in EVs. And I'm pretty sure the original reference that Elon said, "Hey, I know this guy that lives near you, and he talked to us at SpaceX, but he wasn't a good fit for SpaceX, but maybe he'd work out at Tesla."
Interesting. So he lived a block away from me at that time, and so I would go over to his house and see him building the electric 944 that he made.
Exactly.
So that's, he was in my class, so I knew him well. So then you converted the Lotus. Like what happened? Like, how did you guys decide to do that? And when did that all started at that same time?
So during that 6 months where we were trying to figure out if it was possible, like one of the issues is we were pretty sure we could make the battery, it was a complicated thing, but it's ultimately what Silicon Valley does. It's, has lots of wires, and, it's got computers and, network connections and, it's stuff like we know how to do. And the inverter is kind of the same way. The motor, we thought we could get off the shelf, which turned out not to be the case. And we had to actually make our own motors for a variety of stupid reasons. But making the car part, the actual screwing things together part, was something that we didn't know how to do, and we didn't think we could add any value, because the car industry has been doing that for 100 years, and they're really good at that. They're good at bending metals and screwing things together. So we looked around the world trying to find contract manufacturers that made cars, and there are a whole bunch. So not a whole bunch, but there's enough. Magna Steyr in Austria, in Graz, Austria, was a big one. And they, at the time, were making, Saabs and GM vehicles and BMW, I think series, BMW, the small SUV BMWs. And they were contract manufacturing for all these different brands, and making, BMWs or whatever. We had talked to them. We had talked to Noble in South Africa, which also made cars for a bunch of different, car companies. And then Lotus also had a business line that did that. They were a small volume sports car company, but they also couldn't make the ends meet without help, they had a whole design and engineering department, that they outsourced for other companies. And then they'd made the Opel Speedster for GM, and they had made a couple of other cars for other car companies. So we were looking for a company that could do that kind of thing for us. We ambushed the Lotus people down at the LA Auto Show. Martin and I flew down and literally just wouldn't leave until we spoke to people who were kind of higher up in the echelons there from their sort of manufacturing consulting division. And we said, hey, we're going to try to make this electric car. We'd like some help screwing the thing together. They clearly thought we were yo-yos, but they said, well, come to Hethel, and which is in this obscure part of England. We'll talk about it. And we're like, great. I don't think they expected that. So we ended up, a couple of months later in Hethel, England, and negotiated a deal. And they were a good fit for us because they were used to making relatively small volume sports cars that were, sort of small and light, which we needed for the original Roadster.
Did the yellow prototype come after that, or
Oh,
had
yeah.
you guys already been working on that?
Once we knew that Lotus was going to screw the car together for us, what we wanted and what we got were two different things. So that's its own issue. But it turned out that their production facility was not very flexible. We really wanted a slightly wider car. We wanted a slightly different looking car. It turned out that the mechanization that they used to grab hold of the chassis and everything in the production process could only accommodate cars that were the same width as a Lotus, which was inconvenient because it's really narrow. You can make it as long. We could have a hot dog, but they couldn't make it any wider. Meanwhile, we wanted to make a mule. And in the car industry, a mule is something that's not production intent. It doesn't reproduce, which is why it's called a mule. But it's got pieces of one thing and pieces of another, and you put them together and you test them. It's a rolling test bed. Our plan was to have a rolling test bed. We were going to use Lotus, and it was going to be constrained to this width that we didn't really want. We said, well, do you have any vehicles around? And they happened to have one that was stranded. They had brought it out for some kind of demonstration, but it was European spec'd, so it couldn't pass smog or anything, and so they couldn't sell it. And it was more expensive for them to ship it back to England than to just leave it there, as a showpiece. So they gave it to us at a very, very, cheap price, as long as we would never use the engine,
Right.
off of the track. And we were like, no problem. We're getting rid of that thing as quickly as we can, get rid of it. So we took the engine out, and then we used that as our first mule. That was the yellow one.
Gotcha. So I came on when we were working on that, but I came on with I guess, I don't think that one was called Mule 1. That was just the yellow one. And then Mule 1 and Mule 2
Mule
were
One.
after
No,
that,
that was
right?
Mule One. Its official designation of the company was Mule One.
It was? Okay. So then it was Mule 2 and Mule 3 that I guess I worked on there. The gray one, the red one, and the black one was a buck.
Yes, the black one was an Aero buck. Once our design once the style was finished, which they do in clay, because they're artists, so they work.
I remember that.
Once you approve that, and each side of the full scale, clay thing is different because they're working on different treatments and different styling ideas and stuff. And they get one side the way you want it and you approve it. They then digitize that side and then, flip it to make the car. That moment, then it's out of the physical domain and it's in the digital domain. So then you beam the files to any one of these aero houses, and they'll CNC a full-scale car out of a giant hunk of plastic, put wheels on it, and put it in the aero chamber and do all the aerodynamic testing for you. It's turnkey. It's awesome. They have places all over the world that do this. So we used one, and then unlike all other car companies on Earth, the Aerobuck looked so cool, being this sort of black sports car thing, that we wanted it here. We wanted to ship it, back, and we call them up, and they're like, "Oh, no, it's the Aerobuck. We just put them in the shredder afterwards." We said, "No, we want it shipped." And long pause. Like, well, no, we'll just shred it for you. We want the thing. No one had ever asked to have one of these things shipped home, because all the testing is done. Like, you just at the end they put them in the shredder and they reuse the plastic. Anyway, so we had it shipped and it was in our lobby for years. It was great.
Yeah. And I think, is that the one that Greg Rendez took to Burning Man?
Greg Renner didn't do that, but I think it was Greg Solberg might have taken it to
Solberg, yeah.
I think it was Solberg. Yeah, they took it to Burning Man. And then it was never black again.
Yeah.
Gray, because that fine, applied down into the plastic itself and made it kind of gray. But it used to be jet black.
Maybe talk about some of the trade-offs in that early time. So you've already, there was a trade-off of going narrower than maybe you wanted for that line. Were there other trade-offs that you can remember that were really key, like that you were glad that you made, or maybe some that thought about, well, what if we hadn't made that trade-off, or I don't know, any thoughts?
We were now constrained to this sort of narrow form factor. There was a whole bunch of things that we thought we could get easily because we were naive. One of the things that enables small car companies to exist again is that even the big guys don't make hardly any of the parts. the windshield wipers and the windshields and the mirrors and the door handles all come from suppliers. And so we had this vision that we could just go to these suppliers and say, hey, we want, 5,000 of these or whatever. And it turns out that the suppliers just had no interest in dealing with us. I mean, like zero interest. What we had to do was, fortunately, Lotus had relationships with suppliers because they were buying thousands of these things for their own cars. So we ended up getting constrained in a way that was annoying because, if you wanted, rear view mirrors or whatever, the one we wanted, they just wouldn't talk to us because our volume wasn't interesting to them. Whereas, because they were talking to GM and GM wants 1 million of them, so they're going to pay attention to GM. So we ended up having to sort of dive into the Lotus parts bin much more deeply than we had originally anticipated. There was also a whole variety of parts which we also sort of naively thought were either available anywhere or through the regular suppliers that we could get access to that we had to invent. And that was expensive.
So do you think it's changed now, or do you think it's still similar?
Oh, it's so much easier.
Okay.
So things that we could not get at all, everything from LED headlights and LED lighting was unavailable. There was nothing automotive grade that existed or that had been homologated that we could use, except for taillights. Taillights were the only thing that was LEDs that was homologated in Europe or in the US. But things like, we would have loved to put power steering in that car because it's a little heavy. But we couldn't because e-power steering didn't exist, electric power steering. The heating and cooling systems, internal combustion engine cars are so inefficient. They waste, over 80% of all the energy as heat. So it's easy to make heaters. You can just pump some of the engine in. So you have to have resistive heat for electric cars because there's no waste heat. We thought, oh, well, that's just got to be available. Well, it turns out that wasn't. We had to invent that. And same thing with the air conditioning. There was no electric air conditioning because air conditioning is always just running off of the belts that, of the engine spinning. Well, electric cars don't do that. We had to create our own air conditioning systems and stuff. And all of that now is off the shelf. That's completely normal. It's way more efficient anyway. And, even for conventional internal combustion engine cars, but also if you do any kind of hybrid thing or, you have to have, it has to be electric, to make this all work. So we were really panicking about the accelerator pedal. All the accelerator pedals were mechanical linkage still. And there was only one that had been homologated for, sort of fly-by-wire. And that was, I think, a Hello branded one. And fortunately, they had just made it. They had originally designed it, I think, for, I can't remember what car company had asked for it. And so there's an exclusivity period when a car company pays the NRE and stuff. And so that had just come off. So we were, like literally just able to get one of these gas pedals or accelerator pedals. Because otherwise we would have had to invent that too. I mean, like it was terrible.
It doesn't seem like that long ago, and there was really no accelerator pedals that were not cable. Or it's kind of crazy to think how much has changed in the last 20 years.
Oh yeah, everything that we had to invent, was expensive. We had to spend, millions of dollars in developing all of these components that we didn't expect to. We thought we could just source, and it's just like, oh, there weren't any available.
How close was the pricing in the end to what you initially thought?
Yeah, we were pretty close. I mean, we thought we could do pretty well direct to consumer at about $75K, and which we did sell the first ones for $75K. But in the end, it turned out that $100K was really a better margin for us, and the market didn't seem to care. And then also, it turned out that people always wanted, the fancier version. So we just set it to $100K. So we were pretty close, though.
And then when did you start thinking about White Star or the Model S? And how did that cross over with, I'm sure it was like just crazy hectic to try to get everything built at Lotus, and I was kind of part of that craziness. It seems hard to then pull yourself back and then think about the next vehicle.
Yeah, I mean, so there is a natural, sort of moment though, because as things go into manufacturing, the engineers that are constantly changing things, get constrained. They can't just keep changing things. Now, if anything goes wrong, obviously they're making changes. And one of the things we had to do with Lotus and with all of our processes and all of our suppliers was allow a level of flexibility that the car industry had never seen before. So, like when we told Lotus that, well, as you build these cars, we have the system so that we can make changes during the builds. And they were like, oh no, you just changed that at the model year. Like, no, that's not going to work, And then, likewise, some of the suppliers, they wanted 3 or 4 year lead times for things. Like the wiring harness people they wanted 4 years in advance of what the wiring was going to be like. And, like, it's just wires. Like we 4 years is not going to work for us. So there is this moment, though, as the engineers roll off, as the active engineering is sort of rolling off the product that you're, in production.
Yeah.
And the production engineers are, beavering away trying to get the production line up and make that work, taking any failures that are occurring that we didn't catch during testing and feeding those back into the design, to improve the car. The main engineering tasks are kind of done, or at least done enough. So it was before we were shipping the Roadsters. We had a small team beginning on the sedan project, the Model S. As each sort of component was sort of finished there, those engineers were rolling off into the next project, because that was going to be years of work. And it was great because since that one, we knew we weren't going to have all these constraints, and we'd learned so much from the Roadster that, it was going to be a really better, it was just going to be better in all dimensions, because we'd learned so much from the Roadster, and we could start with a blank sheet that we could make the car wider if we wanted to, and we could make it longer, whatever it was.
I'm trying to remember back to when some of that changeover happened when I was there, but I think a lot of it, I know that was started. I remember the seating and the H-point buck for the Model S, like being in the shop and doing all the fitment. It does seem like there was like a big delay from the gear change situation. And maybe
Yeah,
I'm making that up.
they
It seemed
nearly
like that was
bankrupted
a
the
pain.
company. Yeah. We had this. The original design had a 2-speed transmission, manual transmission, electrically actuated, but just a manual transmission. In order to get the 0 to 60 time that we wanted to, and the top speed, it didn't. It was not our core competency. There's this little. We figured, well, the car industry's been making manual transmissions for literally more than 100 years. They should be able to do this. So we outsourced that to a company, and they failed. And then we outsourced it to by this time we were kind of in the press, and a much, much bigger company,
Yeah.
huge company, said they wanted to do it. We said, great. And we gave them, a couple $1 million to do this thing, which was, we were desperate, but it was super annoying. They completely failed. It was a complete disaster. Because they'd never done anything. The car industry is really, really good at, like changing the color of the paint and changing the shape of something. But when it's really doing something a lot different, the sort of core engineers, they just don't have anymore. Those people just don't exist. Anyway, they completely crashed and burned, and which nearly took us down, because it was not our core competency. We didn't want to spend any of our own research and development money, and in that we figured the car industry can make these things, like they've been making them for a long time, which was not true, it turned out. Fortunately, by the time that happened, International Rectifier had released new IGBTs, which are the transistors which control the current going to the motor. And these new transistors were more efficient. They're cheaper, which was great, but they were also more efficient. So, Moore's law kind of ticking away for us. These transistors are super efficient. They're passing enormous currents and only getting, a little bit hot. But by being a tiny bit more efficient, we could put more current through them without them burning up, basically, which meant we could put more horsepower into the motor, which allowed us to go to a single gear and still meet all of our specs. And a single gear reduction is pretty obvious how to do that. It's got nothing. But what that did was it delayed our shipments of the Roadster by months and months, and we were running out of money, and we were depending on shipping, and we couldn't ship. So it was near-death experience for the company.
I remember that. I remember prototypes that were like a hydraulic 2-gear shifter. There was the electronic version. There was just like, there was a lot of pain in that room.
Complete failure of our suppliers.
So was it a trade-off though? Because I think in the end you probably didn't have the same top speed, or did you end up having the same?
Oh yeah, we could get the same top speed. That was the thing. We had more horsepower, so we could gear it to keep our maximum, our top speed, and we could still make the 0 to 60 in under 4 seconds.
Right. And I guess top speed's more voltage really than.
Yeah, we just didn't have enough oomph to make that all happen. We couldn't put enough current through the motor, and we were a little worried that we might get magnetically saturated at those currents, but it turned out the motor had room to run, so it all worked.
The barriers you don't think are the ones that you think the industry has had figured out for 100 years, but they've maybe been doing it wrong. They're entrenched in their ways.
Well, they're incredibly optimized for their particular problem, which, is awesome, right? 100 years of optimization, for their particular narrow problem. But when you suddenly say, oh, we just need two speed, but instead of, like what they normally make, it's only going to be two speed, but the torque is going to be a lot hot,
Like off the
a
chart.
lot higher on it. And we need to have this, electrically shifted. That was just one too many things that were different. They'd never had an internal combustion engine need anything like that.
So was that, I imagine that was one of the learnings. What were some of the other learnings that then went into Model S? What was the biggest, I guess, change, or the
Well, there
biggest
was an
variable?
enormous change in the battery configuration, and it was what we always had wanted to do. Anyway, we wanted to put the batteries in the bottom of the vehicle, because it's where the center of gravity is really low. It's got this great space, and we couldn't do that in the Roadster because of the constraints of the manufacturing, how it had to be built. That was a big one. So that was something we knew we wanted to do, and then we could do it. There was also lots of internal changes into how the batteries are put together because we learned a bunch, and of course the new geometry allowed us to change the cooling and everything else. What other were big changes? Everything was different.
Yeah.
Everything had all of these tweaks along the way that we had learned. So
On the motor, though, the motor was still the AC drive,
AC induction motor,
and it was still like that. Really, had the inverter in the same can. It was was that pretty similar to the Roadster, or did that make?
No. So the Roadster had an external inverter, and
that's right. You're right. Yeah.
Because of the way that the whole thing is put together, we couldn't really do that. But integrating the inverter right into the motor can was the way to go for sure. But that was something we learned along the way, and also things had changed. The processors have gotten a lot better. We could make everything smaller. The IGBTs had gotten better again. Like all these things, work together to allow you to do that kind of integration.
What you know about us and from your experience at Tesla, like what do you think are the biggest barriers now that an upstart EV company has to overcome?
Unlike before, in a sense, they're the barriers that any company has. There's how do you get your brand out there? How do you distribute it well? How do you, keep customers happy? How do you make a product? And exactly what product do you make, maybe is a better way of saying it, which delights the customer and meets their needs. And all of that stuff is all things that regular normal businesses, contend with. And that is a great place to be because it means you don't have to be, inventing electric air conditioning, even though it has nothing to do with your core product, other than just, so you don't want to spend a lot of your development money doing things that aren't going to be valuable in the future, which is great that we're now in a place where all of that stuff is available. So I think that the challenges are really very much like any business, which is exciting because those barrier to entry have really come down in a really good way.
We're obviously going after a new form factor, and there's lots of different form factors, but there's still a lot of vehicles in the world. Like, where do you see some of the bigger opportunities in the EV space?
I think that this idea of being able to hit different markets with different form factors is, the car industry has done this, but, for a really long time, it was like the big three plus, a couple Europeans and a couple Japanese, and they had everything. And the idea of a startup car company was insane before Tesla. We got a lot of that. Even, nation states couldn't do it with Proton and some other of these things. And what's happened is, I think, somewhat because of Tesla, is this idea of customers wanting to buy, a new brand of car, whether, we see this with Rivian and Lucid and, and VinFast, and that they're willing to take that risk to be in a different form factor or to be in a different, to experiment with new technology. I think is super exciting. So I think the market has changed, which is also good. And then EVs are a lot more flexible in what you can do with them, because you don't have to get rid of the heat, because, you can package the batteries in a lot of different ways. The motors, the whole, the sort of mechanical system that makes the car go is so much simpler. You can really do a lot of exciting things in small form factors. And one of the things is that, one of the failures, I think, of the big guys so far has been they've made big cars. People kind of like big cars, but it's also, frankly, a lot easier to make a big car. You don't have to worry about space. Oh, we'll just make the car another half meter. Like, who cares? I think it's exciting to be constrained into a small form factor that'll work really well in the city. There is a market for that. We know that. So the only story that I will say, which shows you a little bit of the difference between Silicon Valley and the car industry.
Yeah.
There was this moment. I mean, there was lots and lots of stories I could tell you about this, but this one I think really highlighted it. And it was when we were testing the Roadster on a frozen lake in Sweden. And these are standardized tracks. All the car companies use them, use the same ones. We were using it at the same time Volvo was, the same time GM was. I mean, they slot you in. You have the track from 2 to 3 p.m. and then the next car. So it's all very controlled and done. So we were testing on this frozen track and to get our traction control and stuff dialed in. And I sent the car and a couple of the engineers there, who worked on traction control and, knew all about that. They would run the car and, the car would spin out and, crash into a snowbank or whatever. They would bring the car back and plug the laptop in and grab all the data and do the modeling and then change the parameters and change the code a little bit. And then they'd run the car out again. Within a couple days, the professional test driver, that's the one that is, the track owns and does this stuff, was zipping around the frozen lake, totally under control. And it was night and day when you get the traction control all dialed in. And we were done. So it was great. We know the parameters, the model, great. And the guys are coming home. And Lotus, who was our manufacturing partner, of course, immediately red flagged the project because that stuff is supposed to take months of some other engineering to do, because you run the car once and then you bring it back and then you print out the data and then you fax it, I guess, to Stuttgart or wherever. The outsourced engineers that you don't even work for you spend a month or spend a couple of weeks analyzing it, and then they send I guess parts or whatever it is that you have to send to for a BMW or whatever. They send them there and then you drive it one time again and you get the data again and you keep doing this, and it takes all winter to dial it in. So they were convinced that because we'd spent a few days and just done it in software that we were fraudulent, that we had
taken some shortcut.
We'd taken a shortcut and it didn't work at all, right? And we're like showing the videos and the data, like you can, it's pretty, pretty obvious.
Yeah.
And it took us about 2 weeks to get the project unfrozen because we had to convince them that no, with this computer thing and with software, you can make these kinds of changes. And if you're the ones actually coding the stuff and controlling your destiny, you don't have to wait for weeks of your contract manufacturer that does this one little traction control computer to do something for you. You can just change the parameters right there on a laptop, beam it in, and be done. And but it took us a couple of weeks to get the project unfrozen. That is just an example. I mean, this was a long time ago, but I have heard stories really similar to that this last year. Industry, they just it's taken them a long time to kind of get with the whole program with software and stuff.
It's a little bit like a California thing versus the world, where I feel like there's a lot of people here who are multi-talented and are willing to learn new things and be really excited about suspension, but also be a great software programmer. Mm-hmm. And that in other, you kind of get outside of these kind of innovation zones. Maybe it's not just California, but people are really like, this is your lane. This is where you stay. You don't.
I am sure that that's part of it. Yeah, I'm sure. I mean, Silicon Valley has that sort of multidisciplinary creativity that is not everywhere. And certainly has not been rewarded in the existing big OEMs.
What do you want to do post Tesla? Like, what are the next vehicles you think should be created?
I don't know what the next vehicles should be. I mean, I'm quite hopeful and excited about the TELO vehicles and seeing them out on the road. Who knows what's next? You never do. The market changes. The technology is always changing. So, we'll just see.
Well, we love having you as a board member and advisor, and really appreciate you coming on and talking about the early days. And I'm sure that we'll have tons more questions for you in the future.
All right. Well, great sitting in for us, and Happy New Year.
Thank you too. Thanks, Marc.